All right, welcome, folks. Welcome to this month's Ask Mayfield Anything. We're going to be talking about lithium-ion batteries, risks, and kind of the way forward. So excited to have this topic with you. So thank you for spending your time with us. And we've got a lot to cover here. Big topic. We were just doing some review, and so yeah, let's jump into this and start in on it. So for those of you who may not know me, my name is Ryan Mayfield, founder of Mayfield Renewables, and been in the industry for going on 25 years now. And this Ask Mayfield Anything series that we do, it's something I like doing. Get to hang out with really smart people on really big topics and kind of go through stuff. So this this topic today that we're going to go through is definitely fits that bill. Real quick on Mayfield Renewables, we are a engineering consultancy. We do a lot of engineering work. We work in the solar and solar plus storage space. And so we do consulting engineering, project engineering, and then the education and training is a big part of what I do and where we spend our time. And so we have venues like this. We also go out and we train at shows. We have events that we put on and classes that are available on our website. So very excited to be able to talk about this subject and just have this outlet to talk with the industry as a whole. So today I'm excited and joined by Matt Paiss and Mike Nicholas, and we're gonna use their expertise. Both of these guys have been in the industry for a while and have their unique perspectives on battery safety and kind of where we're at now, where we're going, and what some of the challenges are that we have. So first, Matt, I'll just go in order here. Have you introduce yourself? You're a technical advisor at PNNL, but yeah, just a little bit about your history and what it is that you're doing at PNNL.
Sure. Yeah. Thanks, Ryan. Thanks for the invite to speak today and to you and your team. So my role as a technical advisor, I lead the energy storage safety efforts for Pacific Northwest National Labs up in Washington. I'm actually based in California. And so I represent the lab on all the key energy storage safety and standard codes and standards. So 855, 9540, 1973, a whole list of numbers. And so that on one leg, I do that. I represent and help develop good codes. The other leg is the education and outreach piece. So efforts like this just try and help the industry understand what the codes are trying to do, where there might be gaps in the codes, and then bring back some proposals. And then kind of the other area of my activity is supporting battery projects that PNNL is working on, either deployment projects with partners that we work with or our own lab-specific battery projects that we're doing.
Great. And just for folks who know, I think it's every other year PNNL does a forum. If I'm not mistaken, got to go last year. I went to see when it was this year, and I noticed that there wasn't anything. So I think it's every other year. But just for folks that are interested,
Yeah. So you're talking about the Energy Storage Safety and Reliability Forum, and we do that with Sandia, and we alternate who hosts it. So it actually
okay.
is an annual event.
Oh, okay.
It's just only at PNNL in even years. So
Okay.
this year, Sandia is hoping to be able to pull it off. It's May 6th through 9th in Puerto Rico. So stay
Oh,
tuned for an announcement for registration on that.
oh, great. Okay, yeah, I'd gone to the PNNL site. That makes sense why I didn't see anything. Okay, that's good to know. Yeah, excellent event. Learned a lot last year. So for folks that are deep into it, I highly recommend that. So thank you.
Yep.
And then Mike Nicholas, energy storage specialist and fire consultant over at Hiller. And so Mike, you've been with us on this before, so really appreciate you taking time to chat with us again. And you've been a wealth of information for other stuff we've done. So yeah, if you introduce yourself to the folks and kind of a little bit of history, because you're definitely you've got some good experience there as well.
Absolutely, Ryan. Thanks for having me back, and glad to be part of the program today. Mike Nicholas with Hiller Companies. We're a fire protection engineering firm doing a lot of the battery energy storage submission, client representation, AHJ trainings, planning and commission hearings as well. Retired recently from Kern County Fire Department as the captain and assistant fire marshal there over the battery energy storage division. We developed the first comprehensive submission guideline package for kind of aggregating a lot of the relevant codes to kind of guide the applicants and get them as informed as possible. We also developed a really comprehensive witness testing program to kind of limit the amount of liability the AHJs assume when these go into their jurisdictions. And we currently have one of the largest battery energy storage projects on a single site at a 3.2 gigawatt hour. They're supporting part of Edwards Air Force Base also. So we've seen virtually every kind of technology come through the jurisdiction when I was there. And a lot of our lessons learned were from kind of fumbling in the initial stages of this back in late 2019, early 2020. But we feel really good about the product that we put out there. And that's part of the pitch that we're trying to create across the industry is standardization. So glad to be here today.
Great. Yeah, thanks for that. And towards the end of our presentation, we'll pull up just a screenshot of the stuff at Kern County. Definitely a lot of good lessons learned there, and we use that resource a lot. And so gonna direct people towards that as well, because it's something I think the industry as a whole can really use and benefit from. All right. So with that, we're going to jump in to the conversation at hand. And for those of you that maybe haven't joined our AMAs in the past, definitely encourage questions. We received a number of questions ahead of time. And so in the Q&A section of the Zoom meeting here, you can submit your questions and we'll try to answer as many of them as possible, and have a quick poll here for you as well. So feel free to ask questions as we're going along. And I pulled out a few of the ones that came in ahead of time. Not going to be able to get to everybody's, but we will do our best to cover those questions as we possibly can. All right. So let's set up the kind of the topic here. Battery systems landscape, kind of the concerns and in industry responsibility. So one of the things that we have, so we are seeing a lot of solar plus storage projects, and we have a lot of mandates from different entities from at the state level down to the community level. So we're seeing a lot of systems going in, and we're the deployment is going pretty rapidly. So I think that's something that we all realize and know. And one of the things that is coming up more and more as we get more and more incidents, unfortunately, there have been incidents, but it's one of the things we can't necessarily shy away from. It's talking about these, whatever the incidents are. And so we're going to talk a little bit about Moss Landing specifically here in a few minutes. And there are other incidents that have gone on. So one of the big things is, how can we as an industry de-risk the lithium ion energy storage systems? Avoiding fire events, of course, is one way of doing it, and then understanding what might happen and reducing the impacts if events do occur. So Mike, I'm actually going to kind of throw something at you right away, on the heels of got me thinking about when you were talking about Kern County going through, and you have quite a large system there. And what were some of the things, even in that stage, this was early on, a few years ago at this point, pretty early on in the whole industry, in terms of reducing impacts if events do occur. So I think when we talked in the past, you talked about O&M and kind of how the system operates in future months, not necessarily on commissioning, but being concerned about in the future. So what was kind of that thought process, I guess, or how were you trying to reduce those impacts through what you're doing at Kern County?
Sure. And I think a lot of it goes back again to consistency and standardization. In the early years, we were finding manufacturers hadn't gone through their large-scale fire tests, which for us as first responders, that's going to inform a lot of our tactics and strategies, because the whole premise of that large-scale fire test is to demonstrate that it won't propagate from an enclosure to another enclosure. So as a first-in-company officer, are you showing up expecting the entire battery yard to be involved, or are you going to be looking at a single unit? So the absence of that large-scale fire test also created a lot of difficulty in coming up with a standard approach for installation. How far apart are these enclosures going to be spaced? Do you have the data to support that particular site layout? And for us, the other thing that we really wanted to do is to set up our first responders for success. So we had an incident command post that was set back 300 feet from the nearest enclosure. It's a very conservative approach for us, and we were fortunate in a lot of regards because a lot of the projects were in areas that had a lot of available land. This approach was basically to set up an area where we could have equipment come in stage. We would have a multi-agency command post set up to have an agency rep there with us, giving us information that's going on in adjacent enclosures to help inform the level of engagement that we needed to have with the involved enclosure. So the other consideration is that we wanted our incident command post and our approach to be upwind. So we weren't going to be placed downwind of an incident that's going to have the smoke blowing over the top of us the entire time. We wanted a water tank on site because a lot of these were not fed by municipal water supplies. So we needed to have some level of available water for any sort of exposure cooling, or if we had an incident that wasn't involving a BESS, but a vehicle that may have spread into a BESS unit by proximity, you know what I mean? Now we have a multiple things on fire that we need to address. So in looking at that, you know, again, that consistency, setting our first responders up for success with a design of our program that was very technology agnostic.
That's great. And actually, a great question came in from Alvin Waters. And so asking about, is this why AHAs are looking heavily at explosion control now? He mentions that dealing with a similar problem in LA County. And I guess I'll kind of pose that to you, Mike, in terms of the explosion control, if that was something that you all were looking at then. And I know that was, I think it was a lot of response to what happened in the Arizona incident when there was an accumulation of gases, and finally when the doors were open, there was an explosion. So I think that there might be.
Absolutely. So Surprise Arizona was a bit of the origin story for a lot of
Yeah.
the battery energy storage industry. And anytime that we see an incident of that magnitude or of that severity, you know, code is a reactive process. It reacts to something that has emerged into the awareness of an industry or a particular type of program that we can no longer ignore. So that certainly became one of the, you know, main topics of concern was how are we going to mitigate an explosion? And NFPA 69 obviously became a primary source of explosion prevention, right? The deflagration panels are explosion control. And in this last version of 855 that's in development right now, there was a lot of discussion about that because, you know, what is going to be the driver? Is it going to be 69 or is it going to be 68? And so at day's end, regardless of a lot of the other auxiliary systems that came in these enclosures, in Kern County, we wanted to default back to how are you going to prevent the explosion, which was an early detection, coordinated exhaust and ventilation to keep it below that 25% lower explosive limit.
Perfect. Yeah. Yeah. And so I think that that's a great statement you made. You know, the codes are, you know, being reactive. We're also trying to project into the future what stuff is going to be, but industry moves so fast. It's hard for codes to be on top of that and ahead of that, really. So Matt, I'm going to throw another question at you. So something that came in ahead of time was talking about saying, you know, so the question was BESS fire safety can be viewed at 3 levels: prevention, management of thermal runaway, deflagration, which Mike was just talking about, and the fire propagation. And so given your role, kind of talking, you were talking about connecting the codes and standards, the question is, you know, do current industry analysis and emerging standards address safety at these different levels? So I guess a little bit on, you know, can you talk a little bit about how codes and standards are maybe evolving a little bit and trying to address those safety levels?
Yeah. So, I mean, the question, I'm trying to really dive in exactly what the question was there.
Yeah, so the question was, do current industry analysis and emerging standards address safety at these 3 different levels? So the person who asked the question basically categorized the standards and everything at 3 different levels: thermal runaway, deflagration, and then fire propagation. And so,
Okay.
you know, how are we really addressing these 3 different distinct areas, I guess?
So I think just real briefly, today where we're at, there's some acknowledgement that thermal runaway cannot be extinguished in a cell once it's begun. And so far, we've not really seen proven products or methods that are not maybe IP dependent on a very specific design that can prevent propagation. in a large scale fire. So what we're seeing is an admittance of some of that challenge, and therefore dealing it with a size and separation like Mike had mentioned. So if you have a failure, trying to contain it to a cabinet of origin and prevent the explosion. So the explosion control, we've seen some really innovative designs in trying to prevent explosions, and thankfully have not seen any real damaging explosions in listed systems. So that seems to be working well. But on the suppression side is still a challenge. And so, as we'll talk about in these next couple of slides, based on a large incident, what are now the consequences if you take that approach?
Okay, perfect. Yeah, I like that. So, so let's go ahead and move ahead a little bit here. And so this one, this is just more of an acknowledgement of, again, a lot of systems going in. We see that, California. So this is, per the California Public Utility Commission, we have a projected demand of battery storage. We've seen a large growth, and then this battery storage capacity, being roughly 20% of the peak demand. So we have a lot of opportunity here, and we're also seeing, as we all know, we have situations where we've already mentioned Moss Landing. There's been other incidents in Southern California where there have been fire events and things like that. And so this is all just really coming into play in terms of just, again, kind of setting that stage more than anything of saying we're well on our way, if not already there, in terms of large scale deployment of these. And so making sure that we are all on doing the best we can in order to make these systems as safe as possible. I wanted to move over to this one. I think that we might be here for a minute or two, but talking about multiple stakeholders. And so you see here we have a wheel talking about lithium battery safety, and all of these stakeholders, and there's probably even more that we could list on, or we could get even more granular in terms of who these folks are. And when it comes down to it, we, as an industry, one of the things, talking with folks specifically down in San Diego, fire folks down there, as an industry, we can't avoid the topic of failures. And we need to make sure that the response, or, during that conversation I was having, it was the first responders need to feel confident when they arrive to a site if they're responding to an event. Well, that's very true, and that holds very true. But we also need to make sure that the folks that live in the area, the people that are surrounding whoever it is that it's in their backyard, they feel confident, they feel safe with what's out there. So, one of the things, and I'm gonna, I guess maybe Matt, this might be the best question to throw at you at the moment, but we actually had and this is a question I get a lot in terms of differentiating between technologies. And so are we getting to a point for the industry where different sub-chemistries, they react different, they have different compounds, they have different materials in them? Should we be looking at the chemistry specific when we're talking about these things? Or, how can we get the stakeholders, I guess, feeling more confident around the chemistries that we are using?
Yeah, chemistry comes up a lot. And in itself, it doesn't necessarily denote that it's going to be a safer technology. I've seen some well-designed NMC systems and poor designed LFP systems. And so I think what's in front of us now is whether or not, when there is a failure, are there additional risks that we need to look at? So the topic of toxic emissions has been coming up quite a bit. And so that may provide some data that might be more chemistry dependent. But at this point, I can't say whether or not, an NMC chemistry is absolutely more hazardous than an LFP chemistry. But as we'll see in the next couple of slides with some of the early data released, it needs to be evaluated. We need to understand it. And So once we have a little bit more data around toxicological implications of some of the emissions, then some of that data can be used to guide. But here's the thing I want to preface all of this discussion around is that the data of what the risks are have to be balanced against the perspective of fire in general. Fire is an accident. It is a failure mode. And we have fires daily throughout the built environment. And so while codes and standards are designed to prevent them, occasionally they happen. And so there's no way to make sure that a fire is not toxic. All fire with visible products of combustion have toxic elements to them. And so I think if the goal is to have something be 100% safe, it's not going to be energy storage. There will not be the ability to have a grid without some risk. I just saw a fire today of a power plant. So anyways, I think that perspective is really important as we try and tackle these.
Yeah, and absolutely. I mean, there absolutely is risk in any energy generation source, right? I mean, it doesn't matter what it is, and it's just there's risk that we have to accept as, I guess, as a society, and how we're moving forward with that. Not to, and to ignore the risk is foolish, and so I think that we are just part of that puzzle, part of that entire thing. I think one of the questions, and Mike, I'm being involved in on the AHJ side, as you were in the past, one of the things I've seen, and this is out there, there's moratoriums being placed on energy storage systems. There's a assembly bill in California that is talking about, setting some limitations on energy storage systems. They're generally large scale, generally front of the meter kind of stuff, but nonetheless, it's out there, and people hear moratorium on a energy storage system, and they don't necessarily think what scale that might be, and sometimes it's not even quite clear enough, I guess, on what that scale might be. But one of the things when I was reading the text and the justification for a moratorium, I read what to me was kind of a difficult statement to read, where it was talking about how energy storage systems are known to spontaneously ignite. And so this is coming from somebody that's involved in that. So I guess my question to you, Mike, is, in a general, we need to include lots of stakeholders. We need to include people, get people at the table and talking about that. I guess, in your opinion, is there a way to kind of help diffuse that fear and kind of get a little bit more education out there for people so that, batteries aren't just spontaneously bursting into flames. There is a risk, but I guess, so my question for you, long-winded one here, but how do we get more people at the table? How do we get the AHJs to understand and provide some more education for them?
Sure, I think that the idea of a moratorium, again, is a bit of a reactionary kind of response to some uncertainties. And every time there's a new incident that pops up that, literally and figuratively sparks the concern of the community, what we're battling, and I sit on a lot of these planning commission hearings, public comment hearings where the public comes in and talks, project presents its, kind of layout and some of the technology they're bringing. And unfortunately, we have a lot of internet experts, right, who are not well informed, who are kind of feeding off of some of the frenzy of bad information that's out there. But the problem that we've seen is that the concern is a concern from the local community of hearts and minds. So even bringing in subject matter experts to be able to testify or comment at these hearings isn't always well received, because we're trying to address a concern based around hearts and minds with technology and with technical data. So I think a lot of local AHJs are really looking to the state or somebody that can give some guidance as far as standardization. And I know I'm going to beat this topic up a lot, but I think it has relevance, on a lot of different levels. And so without there being a lot of clear direction a lot of stakeholders feel like they're having to acquiesce to a bit of the uh, public, court of public opinion that
Mhm.
has a lot of concerns. And to Matt's point, I mean, we're still in the process of getting some valuable data from a lot of these incidents. And as tragic as Moss Landing was, it was also an opportunity to have a ton of optics on the site, on the incident. They were doing air monitoring, right from the get-go. They had a ton of monitoring points. The federal EPA was out there, studies going on now about the soil sampling and so forth. So, the only thing that's going to truly combat a lot of that public fear is going to be quality data. And that data is going to have to come from reputable sources. Because even as much time as I spent a quarter of a century in the, fire department, I switched now to a role of being a subject matter expert, and the accusation is that I'm a hired gun. And suddenly all of my concern about my own first responders and my own fire department showing up out there suddenly gets a lot less traction, which is really kind of crazy because the opportunity to be sitting at the table now in a lot of these code development processes is to bring that perspective of the first responders into that forum and into those conversations. So I'm still advocating every day for our first responders, for our fire department, for our operators, and for our public.
Yeah, and I think so. Your point there about the data and kind of to the first bullet point that we're looking at here, this incident transparency. I think one of the things that we're up against is being the litigious society that we are, getting that data, that real data is difficult. And I think that as we've seen from some responses or some reports that come out, uh, it's kind of sometimes it's even can we believe that? And so I guess for both of you, if we could talk a little bit about the transparency of the data and the quality of the data that we're getting. I know that there was a meeting recently that you were both able to attend, and I mean, I guess can you talk a little bit about that meeting was bringing in stakeholders everywhere from developers, manufacturers, it sounds like AHJs, and trying to understand how to get that data better disseminated. So I don't think there was probably any answers given, but I think that if you guys could talk a little bit about, how that went and kind of who the players were and what that looks like in order to get that data out for us as an industry.
Sure. Yeah. So there was a meeting that was convened by the California Energy Commission and California Governor's Office of Business and Economic Development, the CPUC, and CAL FIRE. And the invitees were manufacturers, integrators, um, research organizations, and so battery safety experts, manufacturers. And there was a couple of short panels where each invited stakeholder, had about 5 minutes just to kind of talk about potential gaps in codes or standards or technologies, solutions that they're experiencing. It was more of a listening session by the organizers. Wasn't a lot of decisions made. I think it was a good opportunity to get those groups together. I'm looking forward to seeing what might come of it. Mike had mentioned, or maybe he didn't mention it, but the CPUC has enforcement responsibilities. They might have the ability to gather information too of data, performance data that might help identify issues with their enforcement arm, that might offer some better safety mechanisms. So that was probably my single most valuable takeaway from it.
And I think California Resources Board was there also. So we were seeing a lot of the big stakeholders in the regulatory side. And one of the things that we were pushing from Hiller is, again, this idea of standardization, not only at the AHJ level, but also taking the opportunity to offer training to regulatory agencies so that we all are singing off the same song sheet. There is some direction from the state level that adheres to submission guidelines, perhaps witness testing procedures and programs. And like Matt had just mentioned, the CPUC also put ESS operators on notice that they would be responsible for testing and maintenance reports in the case of an audit or post-incident. And so that was one of the last things that I put out in December of 23, I guess it was, before leaving Kern County, was a letter to all of our operators advising what the intervals of testing were that we found out of the code reference wise. And, as part of our annual operating permit, we would require that they produce these testing reports. And so the CPUC didn't do anything about intervals. They just advised that these were going to be required and gave a lot of other requirements for daily logs and reporting of different things. But, when we're looking at the long-term relationship of 20 to 25 years with the local stakeholders, how do we ensure operational readiness? How do we ensure that things have not deviated from the time that we witness tested it and had it go live through the life of the project? And so that becomes some of the difficulty because there aren't clear guidelines for how often to change air filters on your battery storage units. Well, most of ours are deployed out in our eastern Kern with the desert, dusty, silty environments, wind blowing 30 plus miles an hour every day. That's not the same hostile environment that you're going to have in a much more tempered environment. So I don't know that a one size fits all manufacturer suggested intervals really apply. So we have to take some of that into consideration, and obviously emphasizing the critical life safety systems. Opening of the louvers, initiation of the exhaust fans, volumes of the exhaust fans blowing out, which again is influenced by your intake. These are all going to be considerations for us as first responders to have that level of comfort, right? The transparency from the first responder, like Chief Resende had mentioned to you, Ryan. We've got to know showing up that this site is as good as it was the day we put it online in terms of its fire protection, detection, and critical life safety systems.
Yeah, no, I think that is a huge part in that. And again, it's just kind of going full circle on that incident transparency. So making sure that, yeah, all those folks, whoever those first responders are feeling confident. And again, that the owners of the site, or the owner of the system, the neighbors of the system, everybody feels confident. So for me, one of the big takeaways in all of our conversations we've had leading up to this is that getting that actionable data and understanding, being able to take information from that and be able to make future decisions on it. So we're going to show you some stuff here coming up in terms of some data collection, and Matt's going to be able to talk us through that. But I think that that's a perfect example of all of that. All right, I'm going to move us forward a little bit. Speaking of data and collection of data and everything, what you're looking at here is, maybe for the people in the audience, maybe this is something you've seen before. So these are some charts from EPRI, and this is a look at failure incidents of energy storage systems and some root cause analysis. Now, I think the thing to be super aware of in terms of this data, and just for the, I was not involved in the collection or the dissemination. Mayfield wasn't, but it's interesting to look at this when you look at the chart on the left-hand side, talking about failures with identified root cause and failures without identified root cause. And this is not saying that there was not a root cause. This is just saying that it wasn't identified. And and this is just going to be, I think, me harping on the same kind of thing, is the data that was collected here. This is really more about what was publicly available in terms of information about these fires. So this isn't getting behind the scenes. This isn't being able to, have folks that are doing the direct investigations per se, but this is publicly available. So very much coming from outside reports and things like that. So all to say that it's not that it's bad data, but it's probably could be viewed as incomplete, maybe is a way of looking at it. And we have a long way to go. And so this is, in my opinion, just helping illustrate the fact that we need to get that data. We need to have access to that in order to provide better systems and be able for AHJs to know exactly what's going on with these systems and how to best protect them, as you're talking about, Mike, with, how are we, what does the O&M look like, and making sure that they feel confident that they show up in 3 years, it's operating as it's supposed to, like it was 3 years ago, not in some deteriorated state because of, the louvers don't open or the filters are full of sand or something like that.
Hey, Ryan, can I make a comment on this?
Yes, please. I was just about to open it up and ask if you had anything to say about it.
Sure, yeah. So this report again was written by a data analytics company twice, EPRI, and I contributed to it for PNNL. And what we wanted to look at was, could anything be gleaned from this database that is based entirely on media reports? And so the details of the failure, even the system itself, is often not there. So that has to be taken with a big grain of salt of these numbers. But I think the purpose of the report was try and see, are we seeing fewer events, and is there anything in these events that we've learned what we know from them? And on the right side there, the pie chart there tells a huge story. And there's a common analogy that the cell is not always the victim, or not always the villain. Sometimes it's the cell. And this is played out in what we do know of the failures. There have been a number of failures that have been due to water ingress or water leaks from cooling systems, poor integration, poor workmanship, lack of quality control. So that I think is a validating set of data right there. And so operating a safe energy storage system takes a whole lot of cooperation in a number of different areas. It's not just cell chemistry or even the tier of the cell, tier 1 or so. Anyways, that's an important data point there.
I appreciate that. Yeah, I appreciate the background on that because, at first glance, when I first saw this, I took it as kind of gospel, if you will, and like, oh, it must have, a lot of data was pulled from this and understanding. And so having that full picture really helps, I think, set the stage and just illustrate that we need to be able to share that data better and hopefully get around the lawyers. But I don't know. That's a bigger question, how we actually do that.
Yeah, one thing I will share is, a large, well-known manufacturer that probably has 15,000 large energy storage enclosures deployed and operating recently shared that they had less than 10 failures out of that. So from a failure rate, that's very low, and those failures have performed as they were designed and expected. So that's a trend that I think is really promising. So more importantly is the sharing of data and not competing on safety. We really want to see manufacturers help each other out. If they've identified something that makes their system safe, but it's not shared, it affects them when there are failures outside. So
Sure. No, that makes a lot of sense. One question that did come in was about existing sites, and I would love to get both of your takes on this. The question says, now that we know there's a problem, and put "no" in quotation marks there. So I think that's not every site's going to be a problem, but now that we've learned things as an industry, is there something to be done about existing sites? Is there something that AHJ should be doing? And I guess that's a question that it's a pretty big question. But do you guys have an opinion on systems that are 4 or 5 years old? Is there something that AHJs could be looking at and trying to get ahead of the curve a little bit?
Yeah,
Mike, you want to take that one?
an important distinction to make is two very different types of installations, indoor versus outdoor containerized, right? And one of the things that we brought to the meeting with the CEC was that in the current version of NFP 855, nothing that we saw in the most recent incidents of reference and that caught everybody's eye in the news surprised that particular committee. We had addressed a lot of these, concerns already pre Moss Landing and pre Otay Mesa. And so we're getting ahead of this. We're anticipating, some of these areas of concern and, trying to get that codified so that it becomes direction on how to do these things ultimately safely, right? But there are two very big differences, you know, when we look at fire risk profile of batteries in a building versus batteries not in a building. And so for the legacy projects, whether building or not, one of the big pushes was, you know, if they're not listed, they didn't have an NFPA 855 direction, you know, because
Mm.
the code didn't exist at the time, or they weren't UL listed in 9540, then they didn't get a hazard mitigation analysis. And so that's one of the pushes that we're trying to encourage is that those sites need some sort of hazard mitigation analysis and evaluation of that design and to make a determination if there are proactive things that can be done to increase the fire safety of those. And there is language in 855 for that currently,
Mhm.
but it's going to be much clearer in the next version that comes out.
That's great. Yeah, no, that seems like a good, I mean, a good workable solution as well. Being able to go back and look and doing those hazard mitigation analysis, being able to understand what the risks are and what the proper solutions are. So I like that's great. A question came in that is a great segue right into this. The question was asking about 9540. So the question is, you know, is UL 9540A sufficient to understand spacing necessary to prevent fire spread, or should we be using something else like the TS 800 from CSA? So for folks that are unfamiliar, 9540A is a testing process, and so or testing protocol that the manufacturers go through to test at the cell, module, and unit levels. And what we are seeing is that part of or the that testing protocol does not include ignition, doesn't require ignition of the cells or the modules when they do go into thermal runaway. We have this CSA 800, and that is what some people are, you know, saying it's a true large scale fire test because there is an ignition source. We are basically starting these things on fire to see what happens with them. So part of the reason I wanted to pull this up was um, just, you know, what are some of the solutions that we're doing? As an industry, we are reacting like you said, Mike, but what are those reactions? And so this is one that I think is a great positive step. It's probably not the silver bullet or anything like that, but nonetheless, it's a step in the right direction. Um, Matt, I'm not sure if you know if you have some things to say about kind of this new test protocol in relation to 9540A, and kind of how you see the two working together for the industry.
Yeah, this has been a long time overdue. We learned pretty early on that the iterations to 9540A were resulting in manufacturers designing their modules just to kind of pass the test, so to speak. So because the test wanted to see a significant failure, it required propagation, the language essentially just required propagation to one other cell. And so now every module that has gone through 9540A is designed to ensure that you have propagation to two cells. That's not ideal. We really want to have a module that can have a propagation resistant design. So the direction towards a large scale test was created. And we're seeing this in the residential space in a outline of investigation called 9540B. And another way of understanding that is ignited plume test. And so, for example, a residential battery can pass the cheesecloth test, no fire coming outside of it. But if those gases encounter a spark or an ignition source, now you could potentially have jet flames coming out. And now it would impact potentially a battery where the manufacturer had said it could be 6 inches away. Now it could potentially perform worse in propagating fire from unit to unit. So that's the purpose of these large scale fire tests, is really to understand what happens if those gases ignite. When we shifted towards LFP, it's not necessarily as energetic of a thermal runaway process, so it doesn't always ignite as readily as an NNC or NCA chemistry would. And so now we're at this place where we have a gap in the technology. So the large scale fire test is really important. It's going to fill, I think, a much needed gap in ensuring that fires don't propagate to the next units.
Yeah. I fully agree, and I'm excited to see this in that we have, something that we can point to. So we have AHJs. I'm sure there's lots of folks out there working within AHJs where the 9540A test data is not that it's not being accepted, but it's the AHJs are still requiring spacing amongst the individual units because of this fact that what you were just saying, Matt, there could be an outside event that could actually light those gases on fire, and we just honestly don't know what would happen. And so this test specifically is there to address it. I would expect, I get this question a lot of like, once we have this, once this CSA test is a consensus standard or consensus test, will the AHJs be accepting it? And, my hope is that they would, because we're going to have a lot better information. But of course, I can't guarantee any of that because the way the codes are written, the AHJs have the ability to accept it, but are not required to accept it.
Yeah.
Matt, there was another question, and you were just talking about gaps, and so I don't know if there was anything else you wanted to talk about. The question was, what are the main gaps when it comes to battery hazards that are currently not covered by any standards, and how these gaps are planned to be addressed in the future?
Yeah, so what we have identified in the gaps with 9540A has led to a discussion around what other tests are really needed. And so I think the real gaps are around a good test for deflagration prevention, a good test for propagation prevention. In other words, can somebody ensure that their module stops at a single cell failure? Like I said earlier, that would not meet the performance requirements today. You have to have propagation. And then the third one would be toxic emissions. We do not evaluate that during tests. And so I think that there's some value to that. There's different chemistries that might present risks that we really do need to design for, gases and products that could be very, very toxic. And so we need to understand that.
Yeah.
And so these tests, even large scale fire tests, I do believe that we'll see modifications to 9540A, maybe even bringing 9540B in as a type of a large scale fire test. So I do hope to see that in the next year or two.
Great. Yeah, I'm excited. I think that's a positive step forward. I think that in order to be able to truly have that data and understand how these systems are operating, that's going to be our step forward. Okay, so speaking of the toxicity data, Matt, I'm going to kind of let you talk
Sure.
about this. This is a video that you provided, and so Moss Landing. But why don't you kind of
Yeah, so if
talk
you
about this?
pause it right there, please. So this video was shared with me by a community member in the Monterey area. And where I think this video is really powerful, maybe if you could just drag the slider back a little bit slowly, you'll see what we're looking at right here. We're seeing that plume start to come to the ground level. But okay, that's good. Yeah. So look at the distance between where the event occurred and where that plume is starting to touch the ground. That's probably 2 to 3 miles there. And that I think is really telling. When earlier we were talking about how the EPA showed up, did a lot of air measurements, did not pick up any contaminants around the plant. Could it be because it was entirely, plume dominated close to the plant, but then further away? I think there was a significant focus on HF, and that was the least of my concerns. HF is very reactive, especially with that amount of heat produced. I did not expect any HF to really leave that site. But there's other materials, and that's where we're at now. So if you want to go to the next slide, another graph. Now, this was a set of data that was collected by a community group that has named themselves Never Again Moss Landing. And what they have done is they wanted to understand what was in that plume that's now potentially on the ground. There was an initial announcement by the Moss Landing Marine Laboratory, which is run by San Jose State, that has been evaluating the slough, which is the marine, ecosystem very close by, for over a decade. And they were able to pretty quickly go out and using, X-ray tools, XRF in particular, and look at the particulates in the slough soils, and they did notice some of the heavy metals. And so this community group um, got together with a local lab and trained about 125 residents in how to do surface sampling with things called ghost wipes. It's a 100 square centimeter wipe. And the residents collected all of those. They were, there was a good chain of control once the samples were brought back to the organizing local lab. Then they were sent off to ALS laboratories, and they used inductive coupled plasma detection methods, which is a much better method for looking at the actual materials. So the problem with this slide is these values don't translate well to the values that the EPA uses for what we call immediately dangerous to life and health, or of the other levels of immediately hazardous. Those are typically done in an airborne measurement. So they're done in a volumetric measurement, like per cubic meter. This is a surface. So the emissions factors that go into, or the toxic factors that go into evaluating what do these numbers mean, is yet to be determined. But again, that when we're looking at this, we're seeing that there's a large dispersion of materials between 5 and 10 miles away. And so I think that this is interesting data, and it definitely is important to have the industrial hygienists and toxicological community weigh in and try and provide some answers to the community. That's all that I really wanted to share with this. I think it's interesting data.
Yeah, I think it's interesting as well, and I think it's also without the context of knowing exactly what the values are, what they what that toxicity level is. It's hard to fully discern. So I think this gets back into sharing data, getting the good quality data, and then putting it out there so that we as an industry, we as a the community around moss landing obviously deserves to know what's going on, what's on the surface of whatever it is that's out there, their homes, their whatever crops and things like that. So understanding that is an important part of it. And so good to see the data is getting out there. But I think that the context also matters in a lot of ways. All right. So one of the last things I wanted to talk about, we mentioned it before, and so Mike, I'll kind of bring you back in to kind of help talk through this a bit. So Kern County has an BESS guide, and I think Mike, you were pretty heavily involved in all of this. I'm sure it's getting updated. I'm sure it's getting used a lot, and I'm sure more jurisdictions than just Kern County are using it. But this, to me, is a little bit more about along those lines of how is the industry responding? How are, and maybe not necessarily industry, but how are we responding as a whole in order to make safer energy storage systems and be able to work with the jurisdictions, work with the local community in order to help them feel more safe, I guess, is the way that's coming to my mind around these systems. So I guess, Mike, could you mind giving just kind of a brief synopsis? I know we're getting towards the top of the hour, so not a ton of time, but just kind of a brief synopsis on, kind of how the guide was developed and, how it's being used.
Sure. Yeah, selfishly, it was developed because we found ourselves devoting gifts of public funds for our consultant to educate applicants. And we really wanted to have an aggregated source that we could pass across the table and be able to say, these are all the relevant codes, standards, above and beyond, complying with Chapter 12 in the California Fire Code, NFPA, all the different relevant codes from there, boiler and vessel standards, National Electrical Code. The problem that we found was some of the more later developed designs of adding, well, we're going to do a direct water inject, we're going to do a direct liquid Novec inject. A lot of these things added complication that the manufacturers and developers were not aware of, because now all of a sudden it triggers a whole other level of code oversight. So this was just our best effort to aggregate all of the relevant codes and standards for a project, be able to hand it across the table to the applicant. And it was our first attempt to standardize our process. And I think in that, there is a lot of benefit to AHJs because I scoured the internet looking for other, departments across the state or even country that had something similar. And so in the absence of it, we really were forced with developing it.
Mm-hmm. Yeah, and I know it's something that we reference a lot and point folks to. So I fully expect there's other jurisdictions out there that are. Thank you very much, Kern County, for all your hard work, and we're going to utilize this as well. One of the things that you had mentioned earlier, Mike, and there was a question that had come up, and I think it kind of relates here. To say, are you aware of any future linking NFPA 855 to other safety codes to further improve the safety controls of energy storage systems? So I guess, do you know of kind of this connection of 855 with others, or even just kind of how 855 itself is going to improve?
Sure. And I think one of the big things we're seeing in 855 as a push right now is to identify that a large scale fire test is required.
Mm-hmm.
And there was some difficulty in coming up with a consensus on the actual large scale fire test design. Correct me if I'm wrong, Matt, but I believe there is some guidance in the appendix, right? Not in the body of it.
Yeah, there's tons of information in Appendix G.
And so that's going to be an area, it's going to be the first time we're seeing a lot of that information, again, aggregated in a central area. That affects everything for us. That gives us spacing between enclosures. That gives us, a real good look at how these are going to perform on their absolute worst day, externally forced into a full fire event. And so for us, these are some of the big takeaways that I think NFPA is going to help with. I think another direction we're seeing NFPA go is pivoting away from NFPA 68 as a primary means of kind of dealing with the explosive potential and pointing more towards NFPA 69.
Okay.
NFPA 68 could certainly be included in addition to, but systems that don't have an NFPA 69 system are going to fall into some difficult permitting
Interesting.
scenarios.
Okay. Yeah, and I know that 855 is on the tail end of all the approvals and stuff for the 26th version, so we will be seeing that language fairly soon in order to be able to implement those. So that's good to hear. All right, well, we're actually getting close to the top of the hour, so just kind of some key takeaways, and wanted to give both Mike and Matt just an opportunity if there's anything else that you wanted to cover. But for us, getting the right stakeholders and the data gathering, those are some really big some big parts. The root cause analysis is a big part of it. So call to the industry for that, and being able to better inform on what the incidences have been in order to prevent the future ones. I don't know if Matt or Mike, if you have anything that you wanted to add to that as a final statement.
Don't compete on safety.
Don't compete on safety. I like that one. Yeah.
Thank you again for the opportunity to be sharing this with a broad group. These are the messages we're ultimately trying to get out. There has to be a grassroots movement at the local levels to want and look for standardization, and there also has to be top-down support from the state for standardization so that we can get these projects installed correctly. And that data is going to be absolutely paramount in order to be able to dispel a lot of the internet experts that are out there saying that, this is going to cause this sort of problem that spontaneously combusts, and we need to correct that.
Right.
And that needs to be an effort that happens, like I said, both top down and bottom up.
Yep. It's very well said. Appreciate that. All right. So for the folks, just a little bit of information. I mentioned some courses that we do at Mayfield. So if you're interested in learning more about some codes and standards, we have some courses online specific to energy storage systems, 855 and National Electrical Code, and some others, fire code and things like that. So encourage you to check that out. And then finally, wanted to put up our contact info. I really appreciate everybody's participation. I appreciate all the questions. I think we got to a lot of them. I know we didn't get to all of them, but I appreciate Matt and Mike joining us in order to help educate. So thank you all very much. And if there's any questions or anything, feel free to reach out to us. Otherwise, we'll see you on the next AMA.
Thanks, Ryan.
Bye. Thank you.